Greetings of the day, dear students. In this video we are going to learn about the voltage division rule and also about the current division rule, and which will be very useful and helpful while solving the problems. When two resistors are connected in series, how to find out the voltage across each element. In this example we will discuss. And similarly in current division, when two resistors are connected in parallel, how the current gets divided and what will be the magnitude of current in both the resistors. That will also be found out with the help of current division rule, and we will see some examples on the current division rule. This, by the time you complete this video, you are going to learn about the voltage division rule and current division rule. Now observe, when two resistors are connected in series, right? Let me indicate the resistor 1 as R1 and resistor 2 R2 and indicate the polarities across the two voltages. Let the voltage drop across resistor R1 be V1 and the voltage drop across R2 be V2, and a voltage source of V is taken, right? As and when these two resistors are in series, right, same magnitude or amount of current flows through the resistor. Very important. In series connection, current will be same. In series connection, in series, what will be same? Current I will be same. In parallel connection, what will be same? Voltage will be same across the elements. Very important, basic, right? In series connection, same amount of current will flow. In parallel connection, there will be same voltage across the elements. Based upon this, now observe, already we have seen the Kirchhoff's voltage law and KVL and also the Kirchhoff's current law, right? Let me apply the KVL. The rule is algebraic sum of the voltages in a loop will be equal to the 0, and we will follow the current leaving terminal polarity. For the voltage sign, what we will consider? Current leaving terminal polarity. Now let me start from voltage source, right? You consider a current I flowing like this. In this voltage source, current is leaving here, so plus V. Now current came up to here. Current is leaving at the negative terminal of the resistor R1, so the voltage across R1 is V1, so you have to take minus V1. Current came up to here. Across R2, current is leaving at the negative terminal, right? So minus V2 equal to 0. So if you simplify, V equal to V1 plus V2. Now let me apply the Ohm's law. From Ohm's law, V directly proportional to the I and V equal to Ri, right? So now voltage across R1 is equal to the, from Ohm's law, current flowing is I, resistor is R1, so V1 equal to I into R1. V2, voltage across resistor 2, V2 equal to current flowing is I, resistor is R2, I into R2. Let me substitute the values of voltages V1 and V2 in the equation. In the equation 1, for example, let me consider it as 1. Substitute the values of V1 and V2 in 1, right? Now V equal to, take out I common, R1 plus R2. So what will be the magnitude of current I? Current I equal to V divided by R1 plus R2. So this is equivalent to the R equivalent. R1 plus R2 equal to the R equivalent. Very important, right? Now see here, V1 will be how much? I into R1. But just now we have found I equal to how much? V divided by R1 plus R2. Just simply substitute that one. V divided by R1 plus R2 into R1. Similarly for V2, in the place of I, please substitute V divided by R1 plus R2, right? So V2 equal to R2 by R1 plus R2 into V. Now from these two formulas, what we can observe, if you want to find the voltage in the first element, it is total voltage times into R1 divided by R2. That means voltage into same arm resistance, divided by total resistance. V1 equals to total voltage into same arm resistance divided by total resistance. Similarly, V2 equal to total voltage into same arm resistance, same arm, arm divided by total resistance. This is the voltage division rule. Now from that basic formula, let me calculate the voltage. You are given a circuit like this. A 220 volts is applied to two resistors R1 and R2. R1 is 10 ohms, R2 is 20 ohm. Now what will be the value of voltage? V2. From voltage division rule, we have seen total voltage into same arm resistance divided by total resistance. So total voltage is V into, we want to find voltage across where? R2. So you take R2 divided by R1 plus R2. Very simple, dear students. Right? Total voltage into R2 by R1 plus R2. So 220 into 20 divided by 10 plus 20. 146.67 volt. Similarly, what will be the value of V1? Total voltage into, I want to find V1. So V1 resistance is R1. R1 divided by R1 plus R2. 220 into 10 divided by 10 plus 20. You will get 73.33 volts. This is how you want to do the problems. Very simple. This is important. For voltage division rule, total voltage into same arm resistance by total resistance. Clear? Yeah. Now let me discuss the current division rule. For example, a circuit is given like this. You are having two elements R1 and R2 in parallel. Let the voltage across R1 be V1, V, and of course all the elements are in parallel. In parallel connection, voltage will be same. In parallel connection, voltage will be same and voltage will be same. This is important basic. So voltage across the source is V. This is the same voltage will be across the resistor R1 and also across R2, because all these three are in parallel. Now let me consider the total current entering the circuit as I. Current flowing through R1 be I1. Current flowing through R2 be I2. Right? Now for voltage division rule, we have applied KVL. In current division rule, please apply the KCL. What is the KCL? Algebraic sum of the currents will be equal to the 0. Algebraic sum of the currents at a node is equal to the 0. Or sum of the entering currents is equal to the sum of the leaving currents. In this scenario, what is the entering current? I is equal to, what are the leaving currents? Leaving away from the node. I2 is away from the node. Observe, I is into the node. Observe the arrow direction. I is into the node. If you observe I1 and I2, they are away from the node. They are moving away from the node. So algebraic sum of currents at a node equal to 0, or sum of the entering currents is equal to the sum of the leaving currents. Right? What is the entering current? I. What is the leaving current? I1 plus I2. Now from Ohm's law, what is that? V directly proportional to I. V equal to Ri. From this, what will be the value of current? Current I equals to V divided by R. All these are from Ohm's law, right? Now what will be the value of I1? Voltage is V divided by R1. I2 will be V divided by R2. Very important. Now substitute the values of I1 and I2 in equation 1. Substitute the values of I1 and I2 in equation 1. So I equal to V divided by R1 plus V divided by R2. Take out V common. 1 divided by R1 plus 1 divided by R2. So this is also same as V divided by, if you take out the LCM, R1 R2 divided by R1 plus R2, which is nothing but V divided by R equivalent. V divided by R equivalent. If two resistors are in parallel, R equivalent will be how much? RA RB are in parallel. Then R equivalent will be RA RB by R1 plus R2. Now I want the voltage V equal to current I into R equivalent, R1 R2 by R1 plus R2. So far clear? I repeat again, dear students, in parallel connection current will be same, voltage will be same. In series connection current will be same. During voltage division rule apply KVL. For current division rule apply KCL. From Ohm's law, V directly proportional to I, V equal to Ri, current I equal to V divided by R. These steps must be visible. These steps are important. Now what will be the value of I1? From Ohm's law, V divided by R1. V just now we have found out, I into R equivalent, whole divided by R1. R1 cancelled. So if I want I1, it is simply total current I into opposite arm resistance. This is important. This is where most of the students are going to commit the mistake. If it is voltage source, if it is voltage division rule, same arm resistance. If it is current division rule, if you are finding I1, then here it should be R2. If you are finding I2, opposite side, opposite resistance, opposite arm resistance, then you have to take here R1. If I want, I write here voltage division rule formula. V1, how we have found V1 equal to same R1 only we have considered, divided by R1 plus R2 into total voltage. If I want V2, what I have done? Not for this problem. Observe here V1 and V2 are same for previous problem. V2 will be how much? R2 divided by R1 plus R2 into V. But in this context, I1 equal to I into R2 divided by R1. You please take care here. This is where you are going to commit the mistake. So total current into opposite arm resistance divided by total resistance, right? So this is the current division rule. Now let me see the small problem. A current source is there like this. 5 amps is entering in the circuit. 5 amps is entering in the circuit. How this current gets divided? Here R1 is 10 ohms, R2 is 20 ohm. Current through R1 be I1, current through R2 be I2. That the total current entering be I. Total current entering is how much? I. This is from the current source I equal to 5. Now if I want I2 equal to total current into opposite arm resistance R1 divided by R1 plus R2. But what is R1? 10 divided by 10 plus 20. 1.667 amps we will get. 5 into 10 divided by 10 plus 20. 1.667 amps we will get. Similarly, I want I1. Total current, you know, I want to find current here. Its opposite arm is R2. R2 divided by R1 plus R2. So 5 into 20 divided by 10 plus 20. This part decides your answer. So 3.33 amps. 3.33 amps. Right? So far clear? Now let me do one more example. You are having a circuit like this. In the previous example, I have considered the current source. Observe. Yes, here current source. Now we will consider the, dear students, observe, now we will consider the voltage source. If voltage source is there in parallel to the two resistors R1 and R2. R1 is 10 ohms, R2 is 20 ohms. Current through R1 is I1 and current through R2 is I2, and the total current entering the circuit is I. Total current entering the circuit is I. At this node point, as it is current division rule, apply the KCL, or no need of doing all the proof again. Directly we know, as these two resistors are in parallel, R1 is parallel to R2. Okay, so your R equivalent, or 1 by R equivalent equal to 1 divided by R1 plus R2. This when two resistors are connected in parallel. If you take out LCM R1 R2, here you will get R2 plus R1, and this is equal to 1 divided by R equivalent. So if somebody asks you R equivalent, it is simply R1 into R2 divided by R1 plus R2. This is the case when two resistors are in parallel. So you can memorize this formula. You are familiar with this formula. R equivalent equal to R1 R2 by R1 plus R2. You don't need to do proof again like this. Directly you can take R equivalent equal to R1 into R2 divided by R1 plus R2. Here it is very clear. R1 and R2 are in parallel. Directly you can write R equivalent equal to R1 into R2 divided by R1 plus R2. 10 into 20 by 10 plus 20. How much you will get? 6.67 ohms. Now what will be this total value of I? In the previous case, the problem is made simple because directly the current source value is given. Observe here. Directly here the entering current is 5 amps is given because it is a current source. But now voltage source is given. We have to find this current. That's the only difference. Now we are finding the I. In order to find I, V divided by R equivalent from Ohm's law. This V divided by R equivalent. V is already given 220 volts divided by 6.67. So 32.98 amps is entering here. How much, dear students? 32.98 amps is entering. Now how it gets divided? I1 will be how much? I2 is how much? Observe, I2 equal to total current into opposite resistance R1 divided by R1 plus R2. Total current just now we have found 32.98 into 10 divided by 10 plus 20. So you will get, on substituting and calculating, you will get 10.99 amps. 10.99 amps. Very, very important. Clear? Right. So let me summarize the things. Dear students, if it is voltage division rule, okay, in a series connection current will be same. Apply the KVL and find out the voltages. If it is current division rule, in parallel connection voltage across the elements will be same. Apply the KCL at that node and find out the currents. Or simply to say V1 equals to or total voltage into same R resistance divided by total resistance. If it is current division, total current into opposite arm opposite arm resistance divided by total resistance. These two techniques are very helpful for you to solve so many problems. Right? Okay students, thank you.